Did you know 70% of women with PCOS are unaware they have it? Polycystic ovary syndrome (PCOS) is a hormonal disorder that affects millions of women globally, causing symptoms such as irregular periods, weight gain, and infertility, while also increasing the risk of diabetes, heart disease, and certain cancers. PCOS is classified into 4 types or phenotypes based on specific symptom patterns. However, diagnosing and predicting PCOS types is challenging as current methods rely solely on visible symptoms and do not incorporate genetic information. This often leads to delayed diagnosis, with symptoms worsening over time, resulting in trial and error treatment approaches and delayed care. Current genetic research on PCOS is scattered, and no comprehensive database exists to link specific gene variants to PCOS phenotypes. This is the problem we aim to solve. We propose PCOSgen, a database designed to store gene sequences from diagnosed PCOS patients and facilitate the comparison of gene sequences from undiagnosed individuals with the stored data. PCOSgen will classify PCOS phenotypes based on symptoms and systematically link gene variant data to these phenotypes. The database will serve as a valuable tool for healthcare professionals and genetic researchers, enabling accurate phenotype classification and data-driven insights. Over time, PCOSgen will evolve into a robust resource that supports genetic comparisons and enhances the prediction of PCOS phenotypes in individuals who have not yet developed symptoms, paving the way for early diagnosis and personalized care. On opening the database, you are provided a choice whether you want to enter a new gene sequence from a diagnosed patient or you want to compare the gene sequence of a person without symptoms to find the probability of having a particular PCOS phenotype. It leads you to this page if you want to enter a new sequence. Here, the user enters the symptoms of a diagnosed PCOS patient. Based on the symptoms, the program classifies the patient into one of the phenotypes, A, B, C, or D. Next, it stores the gene sequence of a particular gene variant under that phenotype. For now, we have used random gene sequences as placeholder data. This approach explains how gene sequences can be entered and compared with actual data from patients. These gene sequences will form the basis of the database. Once sufficient data is collected from diverse patients, this system will allow for comparisons. For example, a gene sequence of an individual without symptoms can be input into the program. The program compares the test sequence with gene variants stored under all 4 phenotypes. For every match, a score of 1 is assigned. This score is then used to calculate the probability of the individual developing each phenotype. It currently displays a high probability as limited gene sequences are being compared. With ample amount of gene sequence data in the actual database, the number of comparisons increases, which allows the database to provide a precise probability of a female developing a particular PCOS phenotype. Our long-term vision includes creating a database that is not only useful for genetic comparisons, but also aids in treatment planning for newly diagnosed patients. For example, this table will store comprehensive data including gene sequences, patient demographics, prescribed medications, and their response to those medications. When a new patient is diagnosed, their data can be compared to the database to find similar cases. This allows doctors to personalize treatment plans based on what worked effectively for others with similar profiles. What makes this project unique is that it combines symptom-based classification, gene sequence storage, and phenotype prediction in one system. By focusing on PCOS-specific gene variants, we eliminate the need for comparisons with normal gene sequences, making the analysis more efficient and relevant. This approach could revolutionize early detection and personalized care in PCOS. Once real genetic data is integrated, the system can scale to support large-scale research and clinical applications. It could also help identify new genetic markers for PCOS. In summary, our project addresses a critical gap in PCOS research and treatment. While currently a prototype, our program lays the foundation for a comprehensive database that could predict PCOS phenotypes, support early diagnosis, and personalized treatment strategies. With further development and collaboration with genetic researchers, this tool has the potential to make a significant impact in the lives of women with PCOS.